Just one more thing here about these routes, and I did reload our router, so that's why you see 30 seconds there for how long the routes have been in, but no configuration has been changed. The key here is we are performing OSPF equal cost load balancing, of course, because the cost of the routes is equal at 74. You can do that, or are doing it, over 4 paths by default. And you can change that with the maximum paths command. That's true with EIGRP as well. One, and then it's maximum paths. Don't drive yourself crazy by trying to find out the value or the range for this command, because I see a lot of that out there on the net. There is no one range. It depends on what router model you're on. It depends on the iOS you're on. I've seen this from anywhere from 6 to 32. So don't worry about that. Just know how to change it and what the default is. And that, of course, is 4 again. And we see that in the output of show IP protocols. We've seen that elsewhere. But that is how you would change that. And you can knock it down to 1. If you knock it down to 1, you're effectively disabling equal cost load balancing, right? Because if you just have one path, you can't do any load balancing. So while you can't disable it all the way by setting it to 0, if you set it to 1, you have disabled equal cost load balancing. Let's talk about this RID thing. Let's go ahead out here and run a show IP OSPF neighbor. And we noticed this early on when we were doing the adjacency troubleshooting earlier. These neighbor IDs and the addresses here were the same. And then when we started building our network, and we had the frame network, the NBMA network, and we had our loopbacks, and we had the Ethernet segment, suddenly we had, for the neighbor IDs, we had the loopback address interfaces. What was the difference? Why do we have that? Well, that's what the OSPF RID, and by default, that RID is the numerically highest IP address of all the loopbacks put on the router. Now, in the previous lab, the RID for each router was the IP address on the router's loopback interface. Now, there are two questions that arise there. First is, why a loopback? Why not a physical interface? Well, a physical interface can become unavailable in a number of ways. The hardware can go bad, the cable can come loose, other bad things can happen, ports can just short out, I should say. But the only way a loopback interface goes down or is unavailable is for someone to actually delete it, which is obviously a deliberate act, or for the entire router to go down. And that's another domino effect, really, because in turn, by doing that, a loopback interface's higher level of stability and availability results in fewer SPF recalculations, and for reasons we talked about earlier, we love that. So that results in a more stable network overall. So it's a little thing that actually has a big impact on the network. And here's the rule that just blows everybody's mind. It certainly blew mine the first time I saw it. I thought it was a misprint. An interface does not have to be OSPF enabled to have its IP address used as the RID. I practically guarantee you're going to be tested on that knowledge one way or another on your exam. If it's a loopback, it just has to be up. And if it's a physical interface, it just has to be physically up. The line protocol could even be down, but the interface's IP address could still be used as the OSPF RID. Now, the next question I know you're thinking is, well, what if there is no loopback address? Well, it's very rare to have an OSPF enabled router that doesn't have a loopback, because loopback interfaces, we use them for so many other reasons besides what you're seeing in the NA course. So it's going to be rare in production networks that you don't have one. Of course, with an exam environment, you could have that situation. If there is no loopback, the highest IP address on the router's physical interfaces is going to be the RID. That's the deal. Now, we can also hard code the RID, because most corporations, most enterprise networks, they're going to have policies, for everything, and there are reasons for that, but they're going to have a policy about what the OSPF RID should be, because you don't want to be looking at a IP address and say, I wonder which router that is, because obviously in production networks, we're not going to have router numbers, right? So what we would want to do in many situations is hard code the RID. If you've watched the IP version 6 section of the course with OSPF, you also know that we've got to know how to do this in case we're in a situation where we're running OSPF for IP version 6 and we don't have any version 4 addresses. Because as odd as it sounds, OSPF for IP version 6 still uses a IP version 4 address for the RID. So you can't even get started with OSPF for IP version 6 unless you have a dotted decimal IP address, a version 4 dotted IP address that is on the router, or you hard code it. So it's not just something to know for the exam. When it comes to OSPF or IP version 6, you might need this command to even get started. Let's go ahead and use it because it is super simple. It just has a repercussion we need to be aware of. And we'll do router OSPF1. It's simple. It's just router ID, and you enter the ID in the IP address format. There are no options, but you do have this warning. You have to reload the router or clear your process in order for this to take effect. This is a super rarity. So obviously this is not something that you're going to do on a whim one afternoon in a production network, because clear IP OSPF process, as I like to call it, I may have mentioned this earlier, is the ultimate nullifier of OSPF commands. It's going to bring all your adjacencies down. Now, if you haven't changed anything else, you should be fine and your adjacencies should reform, but that could take a little bit of time, especially over an NBMA network. Ethernet segment should come back very quickly, but it's not going to be lightning fast with an NBMA network. So what I'm going to go ahead and do is run that command, because we know how to reload a router. You just type reload and that's it. Now, anytime Cisco router asks you a question, and first off, it's asking one word in all caps, reset all OSPF processes, you should probably think about it. And then when you see the word no in brackets, that's the default response. So when the default response is no, you're about to do something pretty serious, and the router's just saying, Chris, you sure you want to do this? And I am sure. So I could accept the prompt of no just by hitting enter. So it's like that thing, it's a self-destruct code or something. I have to type it in manually. I can't just say it out loud. You got to type it in. So I will type it in, and there go my adjacencies. I see where it says from two-way to down. That's normal. Actually, when you see that, when you start your processes over again, it's not like our adjacencies were in two-way. So I am going to go ahead and pause the video, and we'll see how long this takes to come up. All right, it took a couple of minutes there, but we see the adjacency messages just came up. You can see that this was the timestamp when the adjacency went down. That's why I like timestamps so much, because you got your time sitting right here, and you can see I said about 2 minutes, I believe, and that's exactly how long it took over serial. Again, Ethernet segment should come up pretty quickly. And really, that's it. Let's go ahead and verify that. And you can see with show IP OSPF, there's the information right there, 11.11.11.11. You could also see it, OSPF interface serial 0, and it's going to show you the router ID and also show you, of course, the DR and the BDR, and we see it changed there. Let's just go to one of the neighbors and verify it with show IP OSPF neighbor. And there you go, 11.11.11.11. This is too, I want to review this with you. I know I mentioned this, but remember that with OSPF, we've got a DR BDR election going on each segment, because sometimes people look at output like this and say, oh my, wait a minute, how do I have two DRs? Well, the thing is, when you're looking at this output, that this is the DR on the Ethernet interface, and this is the DR, router 1 is the DR on the serial network. So just watch that, because it's really easy to look at and go, oh my gosh. And of course, we know why these dead timers are so different, is that our hello and dead times are so different on the broadcast and NBMA network types. That is it for this part of the OSPF RIT. I'll see you on the next video, and don't worry, we haven't forgotten about those LSAs. Those are coming up.